Hello, welcome to my channel Devops with Prasanna. This is day 22 in Learn AWS in 30-day series. And today we are going to talk about Fargate in the context of AWS EKS. So this is going to be an interesting session because these are the topics which I want to cover. First one is what is meant by Fargate profiles and going deep into how Fargate nodes can coexist with EC2 instance nodes along with a demo. The second one is how the pricing for Fargate nodes is calculated from the AWS side. The third one is in which case you should use Fargate nodes and in which case you should use EC2 instance and which one is better. Yeah, I'm very much excited. Let's get started. Introduction to Fargate. So what is meant by Fargate? So Fargate is a serverless containers for EKS cluster and ECS cluster. So we'll talk about serverless. We'll talk about the data plane now. If you remember, Kubernetes has two components in it, which is called control plane and data plane. Control plane is responsible for all the administrative activities, like having a API server layer or like managing the cluster information, and scheduling the pods to specific worker nodes and things like that. And data plane is nothing but the worker nodes. So Fargate comes into picture on how the worker nodes are being created and managed. So as the name implies, it's a serverless, which means if you want to compare it against like what we saw yesterday, when we created a Kubernetes cluster with a worker node, at the underlying infrastructure, it will create a EC2 instance. And whether we are going to assign some pods to that EC2 instance or not, we are going to pay for the EC2 instance. So that's how the AWS billing works. And in case of Fargate, that is not the case. So we'll create a Fargate profile and we'll create the data plane or worker nodes. But we'll get the cost will be incurred for us only when the pod gets assigned to the nodes. So which means if there are no pods assigned to a node, we'll not pay any charge. As long as a pod is running there, we'll be paying for whatever the size of the pod is. That is the criteria. So for example, like Fargate nodes created only for pods. So it can scale to 0. That is the idea. And it will not create any actual EC2 instance for us. So in like it's going to create some instance, but it's called as Fargate instance and not a EC2 instance. The idea here is we are not going to pay for the time period in which the EC2 instance runs. We are going to pay for as long as the pod runs. That is the difference. And how big the Fargate node, it depends on the pod size. So if you know about the pod, like it has two like parameters. One is a core, the other one is a memory. And it has the request and limit also. So when we define the size of the pod, the Fargate node size will correspond to that pod. And that is what we'll be like paying for AWS also. Which means like we don't need to worry about whether we are over provisioning the cluster or under provisioning the cluster and things like that. And because of this serverless capability, Fargate nodes are slightly costlier than EC2 instance node. Okay, so this is to give a very high level intro about Fargate and how things are. Now we'll take a slightly like deeper look at it. When we talk about Fargate, Fargate profile is the most important component there. What this means is, for example, like we can create as many profiles as we want, and each profile will have a different set of criteria. So those criteria are called as selectors. In this case, like the selector will be based on two parameters. One is a namespace, the other one is a labels. So now I'll try to explain this one with an example. So it'll be like much more simpler. For example, we can create a Fargate profile called dev. Okay. And we can define the selector as the namespace could be like dev. And the label here is like task equal to big data. Okay. So what this means is in the namespace called dev, if there is a pod which is started with a label called task equal to big data, then that pod will be assigned to this Fargate profile, which means it will use a serverless model, and then we'll be built against that pod's capacity, like how long the pod runs and what is the size of the pod. That's what we are going to pay for. And maybe like, for example, if there is some pod which gets assigned to namespace called as default, it means like this pod will not be assigned to this Fargate profile, which means it will be assigned to normal EC2 instance if we have any. If you don't have any EC2 instance, then it will not be like going to the running state. It will always be in the pending state. So this is a Fargate profile, and these are the selectors in which a pod will be mapped to a Fargate profile. Okay, so this is the most important concept. File called as default profile, which means like all the pods which are available in the default namespace or kube system namespace will be assigned to this default Fargate profile for all the pods running in this two namespaces. Okay, that is the default profile. We'll see like how to create a default profile, how to create a Fargate profile with a custom config with the selectors and things like that. Demo. So this is a Fargate profile .yaml file which we have. This is a config which we are going to use to create the EKS cluster. So these are the default things like cluster config. We are going to create the cluster in AP South 1. And the name which we are giving is my serverless Kubernetes. And here I'm having two Fargate profiles. One is the default profile. The other one is the custom profile. So even if I didn't give the default profile, the namespace is going to be like default and kube system. So the way to create default profile is either we can explicitly specify it here, or in the command line also we can specify the flag to create a default profile. But the interesting part here is the custom profile. So I'm saying the namespace is div and the label should be task big data. So once a cluster is created, I'll create a pod and we'll see like where this pod is going to get assigned. So to create a EKS cluster, we'll use the EKSCTL command again. EKSCTL, okay, create clusters -f. The file is fargate-profile.yaml. Okay, sorry. Okay, so it will take few minutes to create the cluster. Yeah, I'll pause the video and come back again. Okay, so the cluster got created and it is successful as well. So my serverless K8s, it set my kube config as well. So if I say kube ctl config current context, so it's pointing to my serverless K8s, which is cool. Now we'll take a look at the cluster which got created here. So we go here, like I have only one cluster, just my serverless K8s. And if I go to compute, you can see there are two Fargate nodes. So the node name starts with Fargate, which means it's a Fargate node. And there are no node groups. And there are two Fargate profiles also. So the first one is default profile. The namespaces is default namespace and kube system. So whatever pod which gets assigned to default or kube system, it will go into the default profile. Whatever pod which assigns to dev namespace, it will go to custom profile. And in the custom profile, we have pod selectors, which means the task should be big data. If the pod contains this label, then only like it will be assigned to this custom profile. Okay, so cool. Now we already have two Fargate nodes. The reason for this is we already have some system level pods running there. So we'll try to explore what are the current resources there. And one more thing which I want to discuss is if I go to my EC2 instance, you can see the running instance is 0 because there are no EC2 instance which are created. The one which was created here is called as Fargate instance, and it is internally managed by AWS itself. We don't have access to this instances. Whereas in case of EC2 instance, we'll be having access to it, and we can have our own SSH keys and things like that to log into that machine and things like that. But here in this case, we can't do any of those things. Okay, so now coming back to this one, we'll explore the cluster and see what we are having. So if you see like the pods in the dev namespace, there are no pods running. If I go to all namespace, I can see there are two pods running, which is like core DNS pods. And these two pods are assigned to these two Fargate nodes. Okay. If I go to nodes, you can see like there are two nodes available here. And these two nodes are Fargate nodes because it's having the prefixes Fargate. Okay. So now what we are going to do is we are going to create a pod, maybe like create three pods with different configurations and see like where this pod will get assigned to. So first I'm creating a namespace called as dev with the label as dev. So this is the first pod which I'm going to create. So it's going to say like Nginx, maybe I'll say custom profile. So this pod belongs to namespace called as dev and it's having a proper label, called task is big data. Okay. And this is like default Nginx image and then port and things like that. And the second pod which I'm going to create is, maybe I'll add a comment here, assigns to custom Fargate profile. Okay. The second pod which we have here is, it's not having any of the namespace, which means it's going to assign to default profile, which means like this label doesn't even matter. So if we have a label or not, it doesn't matter. This assigns to default Fargate profile because it belongs to default namespace. Okay. Maybe I can be very explicit also. Namespace is default. Okay. The third pod which we are going to create is, it also belongs to namespace dev, but it is not having the proper label. It's not having the task big data as a label, which means this pod is unassignable pod. So this will never go to running state. So in case if you have a backup node group and EC2 instances, maybe like this pod could have been assigned to that instance. But in this case, we don't have any EC2 instance running. So if it's not matching with any Fargate profile, it will not assign to any of the EC2 instance. It will not go to running state. This side, I'll say kubectl apply -f simple pod.yaml. Okay, so the namespace dev is created, Nginx custom profile, Nginx assigned to default profile, Nginx unassignable pod. So there are like three pods which got created and we can able to see all these three pods. So you can see the namespace also here. Maybe I'll make this full screen. The namespace is default, namespace is dev. Okay. So only these first two pods can be assigned. Okay. So we'll go and see what's happening in the node side. So we'll just wait for a few seconds, but soon like we'll start seeing a node which will be created. Yeah. So if I go to Fargate, the nodes, you can see there are like two more nodes which got created. Okay. And this got created like just 13 seconds before, and this got created 16 seconds before. And if I go to pod, you can see like these two pod got assigned as well. So these two, the Nginx assigned to default profile, it got assigned to this node, and this one, this pod, it got assigned to this Fargate node, which is cool. So we can see like if it satisfies the selector, then the pod will go to a running state. Okay. So in case of this pod, which is there in the dev namespace, it will not go to running state because it can't be matched against any of the Fargate profile. So if I go here, if I go to events, you can see like there are some taint applied to each and every Fargate profile. So compute type Fargate, and like this pod doesn't have that tolerations defined. So taint and tolerations is a concept in Kubernetes through which we can make sure like only certain type of pod can be assigned to nodes. This pod is never going to go to a running state. It will always be in the pending state. If we come and check the console, we can see there are 4 nodes available, and we have 2 Fargate profiles. And if we go to resources, we can see there are like 5 pods available here and assigned to default profile. So if I go and check this one, you can see the Fargate profile is default profile. So this is a label which was assigned by like EKS itself. Cool. I think like this is what I want to show. And in the events, you can see there is a Fargate scheduler, similar to Cube scheduler in case of the normal scheduling, which happens using Cube scheduler. There is a Fargate scheduler, and Fargate scheduler could be able to assign it to the default Fargate profile. Cool. I think like this is what I want to show. And if we, yeah, so if I want to delete this one, like I can say kubectl delete -f simple pod.yaml, and then all the pods will go to terminating state, and eventually like all the nodes will also be removed. So here there are like only 2 Fargate nodes available because we deleted all the other pods. So which means the billing will happen only for the pods which are running there. The billing will not happen for the underlying EC2 instance. So the problem with the over provisioning the cluster, for example, you can have a very big EC2 machine, but there could be like only one small pod which can be running there. But the problem with the node group is like you have to pay for the big EC2 machine, not for the pod running inside it. So this is advantage with Fargate. Yeah, we'll see a few other concepts quickly. Fargate pricing. So pricing is the most important thing when it comes to Fargate, because that's how we can compare whether it's efficient to use a Fargate instance or a normal EC2 instance. Yeah, so we'll do a quick calculation and work out how the pricing is being calculated. So the Fargate pricing as of today is for one vCPU, virtual CPU, it is this much dollar, 0.042, 1 GB of memory for 1 hour, it is 0.0046. Okay. So to put it into a scenario, let's say like we have a pod running for 10 hours per day, and one pod is going to use one virtual CPU and 2 GB of memory, and we are going to run 10 such pods as part of our workload. Let's try to calculate the price for this particular scenario. Okay. So the pod is going to use one virtual CPU and 2 GB of memory. So for example, for this pod to run for 1 hour, the cost is going to be 2 into 2 GB of memory. So 2 into 0.004655. So this is going to be the memory charge plus 0.04256. So one pod for 1 hour, the charge is going to be 0.05187. Okay. And we want to run this pod for 10 hours per day. Okay. So which means into 10. So this is the charge which we are going to incur for 1 day for one pod, but we are going to run 10 such pods. So into 10, so 5.187. So $5.187 is what we are going to pay for 10 pods to run per day. Okay, which means like if you want to calculate for a month, it's going to be into 30. It's going to be like $155. Okay, so cool. So this is a charge which we want to, which are going to pay to AWS at a monthly level for the data plane alone. Okay, I didn't talk about the control plane part because EKS charges for control plane as well. So for data plane, using the Fargate profile, this is the charge which we are going to pay. So if I say about this, maybe like it's very difficult for us to compare whether it's a good option or not. So what I thought was like we should try to compare Fargate with EC2 pricing. But this is how the pricing is going to be done. And there is like one more parameter which I missed out, which is the disk usage. So there is like 20 GB of disk storage which comes for free. And whatever the storage capacity we use more than the 20 GB, we have to pay at a hourly basis. So that's how the charges are going to be in case of Fargate. So to compare like the pricing with the EC2 instance pricing. So for example, like this is Fargate, this is EC2 instance. we'll take a C5 X large machine. Okay. And in this case, I'm not going to do any hardly things. Okay. To give a worst case scenario, I'm going to take the C5 X large machine. I'm going to run it for one full day. Okay. Or like for one full month. And then we'll know like what is the charge for it. So if it runs for one full month, meaning like whatever the configuration of C5 X large machine is going to be, the total price for the day is 0.19 into 24, which is 4.56. And then total price for the month is $137. If you don't want to use Fargate and if you use EC2 instance, the price is going to be $122. Say it's 137, it's 132. The difference comes in the Fargate pricing. If you see here, like for per hour charge, Fargate's cost is slightly more than the EC2 instance charge. So it's 0.19 and it's going to be 0.17. And if you try to run multiple workloads, and there are like a lot of system level pods also, and if everything is going to be like tied against a Fargate profile, then your charges for data plane is going to be like really huge. So you have to be like very mindful in the scenarios in which you'll use Fargate or in the scenarios in which you'll use EC2. So like in my experience, like if you want to go for a fixed workload at a monthly basis, like it's going to run for the whole month, then EC2 is the best option. But if you want to have a workload which will be like used only for the part of the day. So in this case, if you see like it's running for only 10 hours per day. So if that is the case, then Fargate is a good option. And the one more criteria is with EC2 instance, you can't go below one virtual CPU. So the minimum you can go is like one vCPU. And like for example, X large machine will be having like more number of CPUs. Okay, so that is a capacity which you have to like buy in case of EC2. But in case of Fargate, you can go up to like 0.25 as well, 0.25 virtual CPUs as well. So which means like you can have quarter or half of CPU for a pod, and that will work fine in case of Fargate. So these are the two criteria which I'll consider if I want to choose Fargate or EC2 instance. And again, like Fargate also like comes with a variety of pricing options similar to EC2. For example, like you can have spot pricing or you can have savings plan, which will give you like a lot of advantages against running it on on-demand basis. So for example, if you go for spot pricing, which means all the unused capacity, you can get it for very cheap price, like at a 60% discount. Similarly, if you reserve for 3-year capacity for Fargate instance, you can get it for 50% of discount. So this is something which you can consider. But again, like if you want to choose Fargate, then see like what is the time period in which you are going to run the workload. If it's going to be like only for few hours or few minutes per day, then Fargate is a good option to consider. Also, like if you are going to run pods which are very small, like less than one CPU, then Fargate could be a better option. But try to use AWS calculator and see the price difference, and then choose based on your need. We reached the end of Fargate session. Hope you liked it. Hope you learned about like what is Fargate, how the Fargate pricing is being calculated, and when to use Fargate or EC2 instance. Yeah, we'll meet in another session. Happy learning. Bye-bye.